Hey there, focused learners. Welcome. Think of today's explainer as the start of your own personal hero's journey into geometry. Now I know. Hey there, focused learners. Welcome. Think of today's explainer as the start of your own personal hero's journey into geometry. Now I know. A lot of absolute beginners look at a page of geometry formulas and just feel a massive wave of panic. But as your mentor today, I'm here to tell you that we are going to completely demystify these concepts. We're tossing out the old ways. No more blindly memorizing a giant, intimidating wall of text. Instead, we're going to use a new, highly visual method to show you exactly how every single shape logically connects to the next one. As you'll see, mastering area and perimeter really isn't about rote memorization at all. It's about seeing the hidden logic. Let's get into it.
So, here is our roadmap for today's explainer. We'll start with number 1, the basic building blocks. Then 2, triangles, having the rectangle. 3, parallelograms, the shifted shape. 4, trapeziums, averaging the bases. 5, rhombuses and kites. And finally, number 6, your geometry practice quiz.
Section 1, the basic building blocks. To kick things off, let's clear up a couple of technical terms, but we're going to use super simple language. A really common question beginners ask me is, how do I keep area and perimeter straight? Well, here is the absolute easiest analogy. Imagine a standard backyard. The perimeter is the wooden fence that goes all the way around the outside boundary. So if you're walking along the fence line, you are literally walking the perimeter. The area, on the other hand, is the actual grass growing inside the yard. It's the physical, two-dimensional space inside that closed figure, and we measure it in little square units. Perimeter is the fence, area is the grass. Simple, right? Okay, let's dive into what I like to call the master key. Imagine a simple rectangle, just a basic box with a base and a height. Now, if you want to know the perimeter, remember that's our fence, you just add up all 4 sides, or, to put it mathematically, it's 2 times the base plus 2 times the height. But to find the area, or grass, you simply multiply the base times the height. This right here, this is the foundational formula of practically all geometry. Area equals base times height. Seriously, if you understand this one incredibly simple idea, you are already perfectly prepared to conquer every single other shape we're going to look at today.
Section 2, triangles, having the rectangle.
And this brilliantly illustrates that visual logic I promised you earlier. If you take our standard rectangle and just draw a single diagonal line right down the middle, what happens? You get 2 completely identical right-angled triangles. It's almost like a magic trick. That means the area of one triangle has to be exactly half the area of the entire rectangle. So, if a rectangle is base times height, well, the area of a triangle is simply 1/2 times the base times the height. See? No rote memorization required here. It's just common sense visual storytelling at work. Now here's another very common concern from absolute beginners. Okay, but what if the triangle is leaning over or just looks really weird? Well, check out these 3 different triangles. We've got a right triangle, an acute triangle, and an obtuse triangle that is leaning way over to the side. The beauty is the formula never breaks. 1/2 base times height. Always works. The absolutely crucial thing to remember, though, is that the height must always be a straight, perpendicular line dropped straight down to the base. So even if the triangle is slanting wildly, just measure straight up and down. Let's see how we can tackle a really complex shaded region, kind of like this diagram pulled straight from our source text. The secret to solving this isn't some complex high-level math. It's really just a step-by-step logic puzzle. Step 1. Find the area of the giant background rectangle. Step 2, find the area of that unshaded triangle sitting inside it. And step 3, just subtract the triangle from the rectangle. You literally just subtract the empty space from the total space. It's a beautifully simple, elegant way to solve what looks like a really non-routine problem.
Section 3, parallelograms, the shifted shape. Notice how this visual actually proves a parallelogram is, well, it's really just a rectangle in a clever disguise. A parallelogram is a 4-sided shape where the opposite sides are parallel. But watch this. If you chop off the little triangular piece sticking out on the left side, and you just slide it over to fill the empty gap on the right side, you perfectly recreate our basic master key rectangle. Because of this neat little trick, the area of a parallelogram is exactly the same as a rectangle. Area equals base times height. You just use that straight perpendicular height, definitely not the slanted side.
Section 4, trapeziums, averaging the bases. So a trapezium has 2 parallel bases, but they're different lengths. Kind of a wonky shape, right? How on earth do we find the area for that? The crucial trick here is that drawing a single diagonal line completely splits the trapezium into 2 separate triangles. One has a base at the very bottom, and the other has a base at the top.
If you just add the areas of those two triangles together, you naturally get the formula. Height divided by 2 multiplied by base 1 plus base 2. You're honestly just adding two triangles together. That's the whole shebang.
Section 5, rhombuses and kites. Let's move on and see how this builds on absolutely everything we've learned so far. A rhombus has 4 equal sides, right? And a kite has 2 pairs of equal adjacent sides. The secret to conquering both of these is drawing their intersecting diagonals. Those are the lines going from corner to corner. When you do this, you slice the shapes into 4 smaller triangles. And guess what? We already know exactly how to handle triangles. By adding up those smaller triangles, the formula just reveals itself. Area equals 1/2 times diagonal 1 times diagonal 2. Boom.
Section 6, your geometry practice quiz. Okay, before we jump right into the quiz, here is your clear, highly practical checklist for immediate application. This comparison table shows all the shapes we've covered. Notice how the rectangle is the core foundation for everything. The triangle is just half a rectangle. The parallelogram, just a rearranged rectangle. The trapezium is literally 2 triangles. And the rhombus and kite are calculated using the diagonals that, you guessed it, cut them right into triangles. The logic just flows beautifully from top to bottom, doesn't it?
So what are our top 3 takeaways to help you build some simple daily habits of geometric thinking? First, perimeter is always just walking the fence. Simply add the outside edges. Second, base times height for a rectangle is your absolute master key for area. And third, whenever you see a complex, scary-looking shape, don't panic, just mentally slice it into simpler rectangles and triangles. Honestly, if you make a daily habit of looking at buildings or everyday objects and just breaking them down this way in your head, you'll be practically applying the skill every single day. All right, it is time to test your newfound skills with a quick question straight from our source textbook. Ready? Calculate the area of a triangle with a base of 10 centimeters and a height of 6 centimeters. Think back to our visual of the rectangle being cut in half. I'll give you just a second to work that out in your head.
And the answer is 30 square centimeters. How did we get that? Well, base times height is 10 times 6, which gives us 60. But since it's a triangle, we need exactly half of that rectangle. Half of 60 is 30. If you got that right, huge congratulations. You have successfully applied the master key. Give yourself a pat on the back. You did a great job today, learners. You have officially traversed this hero's journey from absolute beginner to confidently mastering the building blocks of perimeter and area. As we wrap up this explainer, I want to leave you with a quick summary reflection task. Sometime today, I want you to find a complex, real-world shape around your house and just mentally trace the little triangles and rectangles hidden inside it. Look around. What shapes will you conquer next? Thanks so much for joining me today, and keep exploring.